So I was working on the Titanfall 2 no mouse movement video and I wanted to re-record that part of BT7274 where you can't move. That's way at the end of the chapter though, and there's a lot of cutscenes and junk, so it takes time. Heaven forbid you end up having to get to that part more than once for one reason or another. It would be really nice if I could speed this up. There's debate online over whether or not Titanfall 2 is a Source Engine game, and that's for another video, but the main thing is, a decent chunk of Source Engine knowledge transfers over, so I downloaded Northstar, which is a mod for the game that allows console access. Northstar was crashing on me a lot though, so I settled on using something called Vanilla Plus. Yay! Host timescale works and lets us speed up the cutscenes. That's at least something, but we still need to get 2 batteries to plug into BT. Being the game's second tutorial level, this obviously takes a while. What if we no-clip to the batteries? Well, Titanfall 2 doesn't have the no-clip command, but since Titanfall 1 forked from Portal 2, the move type key value probably exists, so if we use Antfire to send an add output input to change the player's move type to the correct number, we should end up doing the same thing as the no-clip command. And it works, except no-clip is now 9 instead of 8. Nice. Now we just... Oh, the batteries haven't spawned. Fine then, we'll just have to no-clip through the intended path so we can hit whatever triggers we need to make the batteries spawn. Well, that worked for one battery but not the other. What trigger must I have missed? I guess I'll go look with show triggers toggle. And that does nothing in this game. Why would that be? Could we do some kind of alternative? I found that there's a tool to extract map data from the game's VPKs, essentially GCFscape for Titanfall 2. Turns out, Titanfall 2's triggers work differently than other brush entities, which obviously you already know all about. Oh, really? Okay, well, other brush entities in Titanfall 2, and all brush entities in every other Source game, work by converting the models that make up the entity into a special brush model. Yes, this is the actual terminology that Valve used, which uses an automatically generated model name that is then quietly put into the model key value, as if it were a prop. This is tangential, but it's worth saying that brush models are not functionally identical to studio models, which are what props have. A prop can use a brush model, funny enough, but a brush entity can't use a studio model. Sprites also use the model key value, by the way. Sprites. The triggers in Titanfall 2, however, have all the data needed to construct their shape stored in key values, which are probably automatically generated by either Respawn's map editor or compile tools. Why would they make this change? I don't know. The shape of every brush that makes up a trigger is stored 1 line per plane. Each plane is stored as 4 numbers, 3 to tell the direction the plane is facing, and 1 to tell the distance between the plane and the entity's origin. Note the lack of any data defining the boundaries of the plane. The apple did not fall far from the tree, as this is usually how the Source Engine stores 3D shape data. The method to turn these descriptions of planes of infinite size into... Wait, what am I going to do with this? The Source Engine doesn't have any method of directly displaying a plane. There's only methods for drawing lines. Normally if I wanted to display a line in Source and I'm not using C++, I'd use the command drawLine, but that doesn't work in Titanfall 2, so I instead had to substitute it with basically the same thing, just being called through VScript. In order to draw a line using this method, you need to supply both a start and end position. Okay, so here's the game plane. Find where every plane intersects with every other plane, which will return to us lines that are represented as 1 point in space and a direction that the line spans across, which is all you need to describe a line of infinite length. Then find where those lines intersect each other to get points, which will give us coordinates that can be fed into a debug drawLine call. The commands could then be stored indefinitely in a CFG file. Outputting to a CFG file has benefits because you can take that and use it in any mod that you prefer that has console access, whether that's Northstar, Vanilla Plus, or Ronin. Cool, but is this seriously necessary? Titanfall 2 is a game with pretty sizable modding and speedrunning communities, much like other Source games, and is on an engine that is still a decently open book. I asked about a game mechanic once and people were literally able to just direct me to the code I was looking for. Surely I'm not the first person to come up with this idea. I searched in the speedrunning Discord for any messages that might show some kind of trigger display so I could just use that instead and call it a day. All I found were pictures where someone had clearly drawn in the rough boundaries of a trigger by hand, or an accurate and precise visualization, but in what looked like Blender. There was one exception. Someone had presented an in-game trigger display, but it was in a yet-to-be-merged fork of Northstar with no binaries or anything packaged neatly. Despite people knowing about this work for several months, the Discord search results show that no one had ever gone through the trouble of setting it up for themselves, instead continuing with whatever methods they used before, likely because they found them much easier. So to answer the question, yes, there was a need for something new, and easier to use. I had never written code such as this before, so it didn't go great. My efforts were generously picked up by OZXZBox, and together we figured out how to turn those planes into line segments, but it was not straightforward. A limitation of brushes is that they need to form a convex shape. If there was any concavity, the plane intersection method would give an ambiguous and unusable result. If you want a trigger with a concave shape, then you have to use more than one brush. This is something that you have to account for when reading the key values, otherwise your result won't make any sense. We found that the first 6 planes of every brush weren't actually necessarily planes of the brush, but rather they were describing its axis-aligned bounding box, and if any plane of a brush lined up with the description of one of those 6 planes, usually flat tops and bottoms, it would just not write out a line for that specific plane because it wasn't necessary. We had done our initial testing on triggers that only had axis-aligned faces, so when we applied that code to triggers from an entire map, we found that the code broke on axis-unaligned planes. I'd like to not attempt to explain the math that was used to deal with this because I don't fully understand it, but OZXZBox figured out how to deal with that. At one point, I found 2 planes in a brush with nearly the exact same numbers. Only one number in the facing direction was different, and the difference was imperceptible to the human eye. It was so small that when the key values were being read in, they actually would ultimately get stored as the same number due to, I guess, floating point precision loss. To fix this, we basically just told the program, hey, you know how these 2 planes are the same thing? Well, just pretend one of them isn't there. OZXZBox also changed the program to use a different method that looked at the intersection of 3 planes at once to go straight from planes to points. That was what I called the project, by the way, plane points. Retrieving the entity data from the map files was an annoying and time-consuming process. With the way the Titanfall VPK tool is programmed, you could only extract one file at a time or the entirety of the VPK you have open at once. Not good. It was also the case that the entity data for a single Titanfall 2 map was split across multiple different files, 5 for single-player maps and 6 for multiplayer. There are 13 single-player maps and 24 multiplayer, so that's 209 files. To make it easier for people to use plane points, I combined all of these files into just 37, one for each map, and put them in a separate GitHub repository. I also include some different lists of which entities appear in different maps and across the whole game. I found it hard to discern which lines belong to which triggers when there were many triggers being drawn at once, so I made some funky code to give them colors based off their position. I still think there's more work that needs to be done in this regard. Plane Points has a filtering feature with many different rules you can define to control what things are shown. This helps to make the information more manageable. A small feature was added to show the origin of an entity, and this is not limited to just triggers. It can show any entity's origin. This could be useful in a number of niche ways. I think I've crushed it overall in terms of ease of use. Here's a demonstration. The project took about 1 week from conception to being in a state I consider usable, though there's still more work to be done. The most notable thing that the project is missing is a way to display information about a particular trigger in-game, which would be a massive help in understanding what a particular trigger does. This is planned to be addressed. A limitation of the project, which probably won't ever be solved, is that it cannot reflect the current state of a trigger or any other entity. It's just reading the position data of how that entity originally was. It can't tell if the entity currently exists or not, and if it's a trigger, whether it's currently active or not. In the case of moving entities, the lines are unable to update to the new position of the entity accordingly. With all of that out of the way, how about some findings I've made? The Gauntlet has a lot, and I mean a lot, of reset triggers in the outdoor area. I'm told that this is because the trigger has to have line of sight to a player in order for it to take effect, so they had to create many different origins. This is not true for any other Source game. They were really committed to locking this area down. So, here are the triggers that you have to hit for the first battery. You have to hit all 4 of them, and the order is not important. For the second battery, you first have to get the first battery, then go through 6 different triggers. This trigger may be hard to see, but it basically just looks to see if you jumped back over to where BT is. Once you hit it, you have to kill the guys that are near BT and then install the first battery. I added a green ball around the battery because it's hard to find it when you're no-clipping. This trigger to the left must have been what I was missing. You can see it's very easy to fly right past it. Many but not all bits of foliage have triggers inside them which make it so that enemies cannot see you. What are these other power sources? These must be the engines of the James Macallan. Interesting. They are pretty big. If you touch 4 specific triggers in Blood and Rust, you'll activate an Easter egg. You'll know you've activated the triggers because each trigger has a bottle associated with it, and when you activate it, the bottle will vanish into the floor or a nearby wall. There's a trigger around a Loch Ness monster in the chapter The Beacon, but nothing seems to happen when you touch it. There are 2 interesting triggers at the end of Trial by Fire. One is the trigger that starts the cutscene, and the other is near the runway, and when you hit it, it will end the level just a bit earlier than it otherwise would have. They did not want you to explore the runway, which is not very well polished. You can tell that this is their intent by this vscript function name. If you hit these triggers in reverse order, you can end the level during the cutscene.
Bliss, this is Sloan. The Ark is headed your way.
Well, that's all I've got for this video. Time to go work on something I'm supposed to be working on.